All right, so now we want to solve problems on two subset, and we're going to be using the Venn diagram and the formula method for solving two subset problems. The question says an induction ceremony organized for 100 level students of the Faculty of Natural Science of UNIJOS. 800 Jambites turned up at the opening ceremony, while 600 turned up at the gala night, and there is a total of 1,234 Jambites. How many Jambites attended both functions? Now, what are they asking us to find? This is what they're asking us to find. How many attended both functions? Now, basically, we explained that when anything has to do with both or common, it means intersection. So they basically want us to find the intersection between those that went to um, the opening ceremony and also those that went to the gala night. So we just need the number of students that went to both events. That is the intersection. The question sometimes can go over your head or be very confusing. So what you do is bring out the values inside or parameters. So let's start from the beginning. There is an induction ceremony of 100 level students. There are 800 Jambites that came for the opening ceremony. So we can say that opening ceremony, let's call it, let's say 800 Jambites, yeah, for opening ceremony. So let's say OC. Then we have 600 Jambites, right, for the what? Gala night. So let's call it GN. Now, they said total number of students, total number of Jambites is um, 1, 2, 3, 4. That is 1,234 Jambites. Now, they want us to find those that went to both um, the opening ceremony and those that went to the gala night. Remember the formula for solving any two subset problem? There is a value for intersection there. The formula was A union B, which is a combination of the two sets, is equal to the number. Let's put the number of A union B is equal to the number of A plus the number of elements in B minus the number of elements in A intersection B. In this case, we'll say that A represents um, the opening ceremony, so that's OC, and B will represent the gala night, that's GN. So now, how do we get the intersection? They've already told us that the opening ceremony, the number of students that went there is what? 800. The gala night number of students that went there is 600. And the total, or the union, which is the total number of Jambites, is, so we'll say A union B, number of A union B is 1, 2, 3, 4. Remember that the universal set here is the same thing as the union because they did not give us any other value or any other element. For example, they did not tell us that there are other students that did not come for any of the two events. Assuming they said that, that means the universal set will be different from this union here. But since they didn't say that, that means the union is the same thing as the universal set. So this is also the universal set. All right? Okay. So now we can put in the values. We can put the union, the number of A, number of B, and then we can find this. Remember that we do not know. So once we do that, we're going to have something like this. We're going to have the universal union, 1, 2, 3, 4, is equal to number of A, which is those that went to the opening ceremony, plus those that went to the gala night, minus those that did not go to any of them. So that is the intersection. I mean, sorry, did I say those that did not go to any of them? Those that went to both. The intersection is those that went to both. All right, so if we solve it normally, we're going to have 1, 2, 3, 4 equals to 1,400. That is 800 plus 600. So that is minus the intersection. Okay. When we bring this to this side, we're going to have 1, 2, 3, 4 minus 1,400. You can also bring it the other way around if it could be easier for you that way. But I want to do it this way. So when we subtract this, we'll have negative 166 equal to negative this, the intersection, and the negative will cancel out, right? So that's the number of students that went to both. To say therefore, the intersection of A and B is equal to 166 jam bytes. So 166 jam bytes went to both the opening ceremony and the gala night. So let me just confirm this solution I did here. So 1400 minus 1234. Yeah, that's it. So this is how you use the formula method. But what about the Venn diagram method? So the Venn diagram method is actually the simplest method to use in solving set problems. But you may disagree depending on you. But let's see. So first things first, draw a Venn diagram. Now, because you have just two sets here, you're going to draw just two circles inside the Venn diagram. Now, since we have um, set A representing opening ceremony, so this time we'll just put it as usual. We'll just say this is O. This is for opening ceremony. And gala night, we'll call it G. They also give us the values for each of these sets. The opening ceremony, the number of students, 800. Now, please take note, we're not putting the 800 inside the set yet. We're putting it outside, attached to this set symbol. And gala night is 600, right? So we'll put it outside. The universal is here, which is the same as the union. So it is 1234. All right. Now, remember that the middle part, which is the part joining the two sets, is the intersection. Do we know the intersection? Do we know the common element? No. That's what we're looking for because we want to know the number of students or jam bytes that went to both the opening ceremony and the gala night. So we'll call it X. Now remember when we discuss Venn diagrams, we mentioned that this part here is only A, but in this instance, only opening ceremony students. This part here will be only gala night students. So that means it's going to be opening ceremony minus the intersection to get us only this part here. And the same thing with gala night. The number of students that went to the gala night minus those that went to both will give us those that went to only the gala night. So here we're going to just put, let me clean this. So here we're just going to put 800 minus X, and here 600 minus X. We've explained this in the last video, so I just hope it's not strange to you. So for us to be able to now solve and get the value of X, we're going to now find the union or the sum of everything. Because basically, everything in these universals, in this set, in this Venn diagram, is 1, 2, 3, 4. So 1, 2, 3, 4, which is the universal set, is equal to the first set, which is 800 minus X plus X, so 800 minus X plus the intersection plus 600 minus X. That is everything inside here. Everything inside here is 1, 2, 3, 4, the universal set. So now if we solve this, we're going to have 1234 is equal to, if we open it up, we'll have 800 minus X plus 600 minus X. Now we have minus X plus X, so this will cancel out because minus X plus X is 0. So we'll be left with 1, 2, 3, 4 is equal to 800 plus 600 minus X. And you see we get back the same equation we're working on before. And this is 1, 2, 3, 4 equal to 1400 because 800 plus 600 is 1400 minus X. And this time if we bring X to this side and 1, 2, 3, 4 to this side, we're going to have, let me solve it here. We're going to have X is equal to 1400 minus 1, 2, 3, 4. And that means X will be 166. So we got the same answer. So that means the number of students that went to both events is 166. So if you have any question on this, well, you can still ask, but this is how to solve a Venn diagram problem using two subsets. We're going to solve more problems in the next video.